This particular workshop is an introduction to quantitative methods. While I'm presenting, I will not be able to see your chats or hear your questions, but when the presentation is done, we will make time to discuss some of the queries, the questions that you might have. What are the goals of today's workshop? Well, first of all, I'm going to give you the general features of a quantitative approach. What is it when we speak quantitative? Does it just mean stats? Does it mean a lot of tables? What is a quantitative approach? Then we're quickly going to look at what do we mean by concepts and variables and measurement. Then those two difficult things that we always deal with, reliability and validity, and how does quantitative see this? Then we're going to look at data collection strategies that are used in quantitative measurements, sampling strategies, and quantitative data analysis strategies. And then we're going to wait a little and see what are the practical implications of this approach. Now, I want us to see today's workshop on the quantitative and the next workshop on the qualitative as actually being two sides of a coin. So I'm going to describe quantitative and then later qualitative with the view to contrast those two approaches because they are different. And what I want you to think of when you think of your approach, what do I mean with an approach in your methodology? I want you to think that you're standing at the top of a road. And at the end of the road is achieving your research objectives. But when you walk down this road, you need to choose one of two paths that fork in the road. You can choose a quantitative, you can choose a qualitative, and then you can combine the two and do a mixed methods. But you must stay on that road. In other words, we can't start off quantitative and then move into qualitative. And we can't start off qualitatively and then halfway through go quantitative. That would be like crossing the road in a very busy highway. We will cause a collision. So whichever road you take, there are certain steps in place, certain words, certain concepts, certain steps that actually makes that orientation that we need to stay true to. So before we start, I want you to understand that when I'm speaking quantitative, I don't just speak about statistics and numbers. I want you to think of quantitative as a method or an orientation that follows a pattern that we decide on beforehand, or as some textbook would call it, a priori design. In other words, before I even start, I've got my steps worked out. That is what quantitative does. I also want to warn that this is a general overview and not specific to your discipline. So this would give you general ideas of what quantitative does, and you will fill it out based on the discipline in which you are doing your research. That these are broad strokes and exaggerations, because in this quantitative bag of tricks available to you as a researcher, there are many different permutations. So I'm giving broad strokes. I also want you to understand that the quantitative versus qualitative divide is often exaggerated, especially when we teach methods. We exaggerate it, we present it as ideal types so that you can understand the different assumptions. But we must see quantitative and qualitative as rather a continuum and two endpoints. And between those endpoints, there are many degrees of overlap. In other words, you might decide, no, quantitative is not for me and would not suit this particular research problem. I'm rather going to go qualitative. But even in that very qualitative study, you might perhaps in your first chapter or in the background description of your research problem decide to include some quantitative measurements, because maybe, for example, you want to say that this problem is increasing or becoming more prominent. Then you're going to put bits of quantitative in your qualitative study in any way. So we exaggerate them a bit, but as a researcher, you must see that all these things are available to you, but it is the logic of how you pack it together that will make your study successful. Then I end off with, say, tell a compelling story. In this week, I had one of my doctoral students saying, I am so confused right now. I've got comments back from you as my supervisor. I've got comments from my language editor. And then I sit with my Turnitin report. And between all of that, I feel lost. And then we had a lovely conversation, and we got back to that point where I said, but the story of the research is your story. Just make that story compelling, make it your own, and be convincing. And the convincing, dear fellow researchers and students, is all about how I can prove that the methodological decisions I've made would actually give the best answer to my stated research questions. I also want us to think of concepts that we use, and here I have to warn you that some methodological books are very, very irresponsible and loose in their use of concepts. But we need to have it clear in our minds before we start our own research journeys. And that is that methodology, the ology part of it, tells us that it is a philosophical stance or a worldview, a way of looking at the world that underlines and informs a particular style of research. But methods, the first part of that word, is about how I collect or generate data and how I analyze the data. So methodology and methods are sometimes used as synonyms. They don't mean the same thing. The methodology is also the philosophy. The methods is just how do I collect and how do I analyze. Then a research design, that tricky part in all our research, is a strategy that justifies the logic, the structure and the principles of your methodology, in other words, your worldview and your methods, and explains how these relate to the research question. And in that definition, we see all these key words. There's a logic, there's a structure, there are principles, the methodology and the methods must match, and in the end, they must match that research question. That is why a research design, I can't go and copy from somewhere else. A research design is unique to your study because your research questions are unique. The function of a research design is to ensure that the evidence obtained enables us to answer the initial questions as unambiguously as possible. So the key thing in all of this is also my research question. When I talk about orientations, quantitative versus qualitative, and mixed designs, then I am talking about a certain subsection in your proposal structure. You all have dealt with proposals, but by now I just want to show you where in the structure we are. We're at the research methodology, usually a proposal or a final report, or a thesis or a dissertation would roughly have a structure like that, where there's a title, there's a problem statement, there are research objectives, there's a scope or delimitation of your study, there are the envisaged limitations of your choices, there's the literature review and your theoretical design, there's the discussion of the importance of your study, why is it being done, And then we have a research methodology, we have the ethical considerations, you've set out a time framework, you've given chapter layouts, and your list of sources. So we are here at 8 at research methodology when we're talking about orientations. So the research design and the methodology. When I start taking these decisions, and remember I said everything must be motivated, it must be substantiated. You must convince your reader, why did I take this choice? When I think about my chosen approach, I need to convince the reader why my methodology fits my topic. And when I think of these reasons, when I put these puzzle pieces together, 4 issues needs to be at the back of my mind. The first is my study descriptive? Is it explanatory? Is it exploratory? Is it emancipatory? Is it critical? And we must make sure that we understand what those definitions mean and how it relates to my study. And some students think that qualitative studies are descriptive and quantitative ones are not. No, each study does have a descriptive element in it, and then it comes down to whether we're explanatory or exploratory, whether we go quantitative or qualitative. And that distinction will become clearer as we go on in today's discussion. Then I also need to decide whether I'm qualitative, quantitative, mixed methods, experimental, whether I'm doing a meta-analysis or document review or desktop review. Is my study cross-sectional? That means I'm doing it in this time. Cross-sectional means at this time. In other words, when I do a sample study or when I interview a group of heads of household at a fixed time in a survey, then I'm doing cross-sectional work. I'm telling the world this is what people experienced or what their opinions are at this moment in time. Longitudinal is where I follow it up over time. Let's say I'm looking at housing provision between 2010 and 2020, then that's a longitudinal study. I measure it. What was it like in 2010? Have we delivered on housing provision by 2020? That's a typical longitudinal study. Then I can also, in terms of my time element, decide whether my study is prospective, that is something that's going to happen in the future. Let's say your interest is on people who are displaced due to environmental degradation. Then your prospective study might say this area where the people live is becoming increasingly unlivable due to environmental degradation. So prospectively, I think that the migration from this area will increase or whatever. Most studies are retrospective. In other words, we measure it at a point in time, but we want to understand perhaps what are people's experiences of food security, and it is for the last month. How much food did the household have? How much income did they have to expend on foodstuffs? So it's retrospective. So think of how we use our time in our study. And then number 4 is the most important one. That's the one where we, as the people who adjudicate research, even if you adjudicate someone else's research, that is the final test of whether you really could match everything. Is there a match between your research design and your objectives? So the research objectives are very important. What is unique to a quantitative research design? What makes it different from other designs? Quantification is about numbers, data as numbers. It is about statistics. Don't let that put you off though. Some students say to me, I'd rather do qualitative because I'm not good at statistics. That's not the best reason for going qualitative. Statistics are not scary. They are often safer to use because there are rules for deduction that we can follow in, and there is always assistance around. So don't be put off to go quantitative if your research problem and your objectives calls for a quantitative study. Quantification is very systematic. Systematic means there's a planned route. I go from point 1 to point B and then point C, point D, and so on, and I don't go back and forth. It's systematic, it's well planned, it's pre-planned. There's a lot of standardization. That means I keep things fairly fixed. And the reason for it, I will explain later why we standardize a lot in quantification. Our typical quantitative research designs would include experiments, cross-sectional studies, many cases observed in one point in time, like surveys, or using existing statistics. Maybe I want to look at unemployment statistics for the youth, and I'm using statistics that was gathered by Stats South Africa. Then I'm using existing statistics, and I'm still quantifying it. Longitudinal designs, that I've explained a longitudinal design earlier, but it's also panel or cohort studies. Wits famously did the birth to 10 cohort study where they followed up babies from birth to the age of 10 to follow up on certain health achievements of those babies to see what impacted on their health. Case study research can also be quantified. A case study can be quantitative, qualitative, or mixed methods. Your typical research objectives in quantification is to measure. So if you look at your research problem, and in that research problem, you're saying, I'm measuring something. I'm actually looking at its current status and looking at whether this phenomenon became bigger or smaller or changed or became more complex over time. Or how does this phenomenon that I'm interested in vary between different groups of people? Then that's a clue for you that you are going in a quantitative route because it's typical measurement. When I want to evaluate something, it's often quantification because evaluation would say, these were my original goals, these were my inputs, what are my outputs? Students, using the word impact in your title or in your problem statement really does mean that you want to go the quantitative route. Because impact means that you're thinking that something was an outcome and that factors impacted on that outcome, and that implies quantification. When I want to predict something, maybe I set up a nice questionnaire to measure people's job satisfaction, and I think that can predict whether somebody would stay in a company for longer, then that is a quantification prediction type of study. When you use the word test, I want to test the relationship between variables. I want to look at impact, or I want to discern what are the causes and the effects of something. Then we're on our way to quantification. What are the steps in a typical quantitative research process? As I said before, quantification is very step-like. It's very systematic. It goes from a first point to a last point. So it starts with theory. You go and read your theory. From your theory, you might derive a hypothesis or research questions or objectives. Then you set together a research design. You devise ways to measure your concepts. You select a research site. You select subjects or units or people or respondents through your sampling. You administer an instrument, a data gathering instrument, such as a survey questionnaire, or perhaps a checklist, or a standardized scale. You process your data in some way. You analyze that data. From that, you derive findings and conclusions, and you write up your findings. And from that, you generalize back to your theory. So those are the steps, and they're very clear, and they need to be there in your study if you chose quantification. A typical quantitative research design follows deductive reasoning. What is deductive reasoning? Deductive reasoning means I started with my theory, I did my literature review, I could see what other researchers found and said about this phenomenon that I want to research, and from that I form a hypothesis. I then collect my data in an investigation of this problem, and then I analyze my data to prove the hypothesis is false or not. It helps when we look at the differences between qualitative and quantitative orientations to help it crystallize for you why I said when you choose one path, you need to stay true to that path. So let's look at the first row there. Qualitative usually use a non-probability sample, whereas a quantitative orientation would typically use a probability-based sample or a random sample. In other words, every element that I select in my sample must have a known and an equal chance of being selected in my sample when I'm going quantitative. The reason being because I want to generalize from what I found from my sample back into the whole population. In other words, if I say in my sample, typically half of the households are food insecure in the middle of the month, I need to say, because it's true for my sample, based on the probability of my sampling that I've done, it also is true for the whole population of the study site in which I sampled. That is what that probability-based sampling means. Qualitative is non-generalizable and subjective. It's ideographic. It's about telling the story as people have it as lived experience, whereas quantitative would always generalize. What I found from my sample is true for everybody. There are a few outliers, but these are the major trends. And if this is true for my sample, it's true for my population. It's objective. In other words, we try and keep emotion away from it. It's nomothetic, meaning it's law-like. That's why we can say if these variables test together, that they cause this effect, then it's likely so that these are the true causes of this outcome. So I become law-like in my prediction of these variables cause these effects. If you've got this, you are likely to have this outcome. Then qualitative also tries to answer what, why, how, and understanding behavior from the actor's own frame of reference. Whereas quantification asks how many, when, where. We try to predict and control. If I'm talking impact, I want to predict if I've got this, this would be the outcome. Other variables I can eliminate. We seek facts and causes of social phenomena in quantification. Qualitative is formative, it's descriptive, it's exploratory, it's inductive, it is holistic, whereas quantitative is hypothesis testing. I verify. In other words, what I read in my theory, does it hold true for this sample? So it's verification based. It is deductive. I start with my theory, I gather my data, I go back to my theory. And it's particularistic. That means it's not holistic. I can't possibly go out there and measure every possible factor. I beforehand state that I will limit my discussion or my measurement to the following variables. So it's particularistic. Qualitative is all about rich data, it's time consuming, and we're looking for an insider perspective, which is also known as the emic view. Whereas in quantitative orientations, the data has to be efficient. Because I said, look, we're going in, we're doing a cross-section, we're administering our questionnaire, we're not going to stay in this poor person who we sampled household for the next month. We're going to gather our data, gather the data at the next household. So the data has to be efficient. And because of that, we may miss some contextual detail. So a quantitative approach is a little bit more of the outsider perspective, or the ethic view. In qualitative, our designs emerge as the story unfolds, and it assumes a dynamic reality. In quantitative, the design, because of that systemization, is decided in advance. A priori, we decide these would be my steps. It assumes a stable reality. In other words, it assumes that if I decide to measure this, when I go out there and apply my instrument, I will find that my instrument is reliable and valid. In qualitative, the researcher is the instrument because you need to observe a lot, you need to listen, you need to write notes. And the data gathering is naturalistic and uncontrolled. Whereas in quantification, we use various tools and instruments, and we try and control the environment in which we measure it. We try and take the background noise out. Let's look at two examples of a quantitative research design that comes from published research, so that we can see those characteristics for ourselves. Here's an example one. This person wanted to look at factors that influence the early adoption of green electricity by residential users. And what they did was a telephone survey that was conducted among a random sample of adopters and non-adopters of green electricity. Look at those clues there. A random sample, and we're comparing two groups, people who adopt green energy, people who didn't adopt it. Comparison between two groups, clues that I'm looking for quantification. Variables for early adoption were developed from literature, in other words, deductive. I started by reading my literature, developed my questionnaires from there, and tested in a structured questionnaire. All those things are clues. Can you see how this researcher is using the bag of concepts that fits with quantification to describe what they've done? Here's another example. Poverty and inequality in international development discourses. That sounds so qualitative when you first read it, but look at what this researcher has done. They say international development agencies pay less attention to inequalities than to global poverty. And what they did is a documentary analysis is used to see how inequality and poverty are framed in different agencies' policy publications. The documents included was the World Bank's World Development Report, the United Nations Development Program, Human Development Reports, and a set of white papers by bilateral donor agencies. So the people used documentary analysis, but literally went and count how many times do they use the word inequality versus poverty. Here's a tip for when you write your quantitative study, how to put it all together. You can write it like this. You can say the purpose of this, and then you give the tradition. The purpose of this quantitative study is to understand, describe, or explain What is that central phenomenon of your study? 4, the unit of analysis, person, the group, the site. So there's a formulation that you can have, that you can use to describe what your study is all about. And I say they demonstrate in all aspects of your work an original critical stance and a unique perspective. Now, I know people struggle to set up their problem statements. It is one of the most difficult parts of your study. Whether you write a thesis, a dissertation, a research report, or whether you're writing an article, getting that central problem statement right is a very difficult task. So here are a few clues. A problem statement must have 4 subparts. And often people just do number 4. They forget about steps 1, 2, and 3. So when I set up a problem statement, I first need to have a principal proposition. That is where I start deductively from my literature. So I say the literature suggests that X is most effective. Adoption of green energy, greater job satisfaction, the empowerment of women, the livelihoods of people in this area. My literature says this, so that is my principal proposition. Then I move into an interacting proposition. This is what's known, but there's a gap, right? This is known. However, while the benefits of X, empowerment of women, green adoption of energy, housing provision, food security, are clearly defined in, you can use the Constitution, National Development Plan, other legislation, other research, implementing strategies lag behind, or this problem occurs. In other words, we connect what is known, what is unknown. What is the problem? Then I've got a speculative proposition that says, because we know that this needs to happen, but it's not happening. We need to understand more about, and then I get to my problem statement, which is your explicative statement. Therefore, the purpose of my study is to investigate. So that will help you to make a stronger problem statement. So if you get a comment back from a supervisor or a commenter who says, there's no clear problem statement in your work, try and put these 4 steps together and see if you can come up with a stronger problem statement. If you chose quantitative, each one of these propositions need to suggest quantification. So I say the research objectives stemming from that problem statement must suggest a typical quantitative measurement too. You must go and assess each of your research objectives against so-called SMART criteria, which is it needs to be specific, it is aimed at something, it is well focused, and it's a research objective. Not what can people do, what can the government do with my wonderful piece of research that it can improve its policies. No, no, no. Research objectives is not what people are going to do with your findings. It is about what are you going to find out. So they've got to be measurable, and in terms of a quantitative orientation, they need to be quantifiably measurable. They need to be achievable. They need to be relevant, and they need to be time-bound. Also, your research action verbs need to be fit your objectives. For example, if you do a descriptive study, you use verbs such as, the goal of my study is to review or identify or discover or describe. When I explore, I say, I explore or I discover. When I explain, I say, I analyze, I compare, I examine, I verify, I test, or I estimate, and so on. These are not an exhaustive list. This is just to help you think that the words that you use when you set out these key elements are so important. There was a study very recently where a student did a lot of work, but he said, the goal of my research is to measure the impact of foreign aid money on the economic development in country X. Now, can you see, if you listen to that very carefully, all of those were typically quantitative measurements. Foreign aid money, we can go and measure it. Economic development, usually we measure it in terms of job creation, income, GDP, and so on. Typically quantitative, and he used the word impact. And then he went and he did a qualitative study. Can you see, we need to be so careful about matching what we say we're going to do with the right words that shows people I've chosen the right path for my study. Here's another example of typical quantitative work. This person writes about food security, and he says the study examines the linking things, already quantitative, between receiving remittances from household members working outside the region and household food security. The survey questionnaire lists all household remittances received from their members in the past year. Can you see it's a time-bound measurement, it's a questionnaire, it's standardized, it's a survey, it's cross-sectional, all these things are quantifiable. The remittances are comparison with incomes, quantitative, to see how much remittances add to the monthly household income. Household expenditure between remittance receiving and non-remittance receiving households are compared according to average spending on food, healthcare, and education. Households are asked a series of questions to assess if at any time during the year preceding the survey they experienced food insecurity and food shortages. Here the person used all the right words to show quantification. So when we look at quantification, we need to operationalize our measurements. Operationalization is key in a quantitative design. Operationalization is the word we use when we take a concept, such as food security, and we go and make it measurable. What does food security mean in a household? What does income mean? How am I going to measure it? What does remittance mean? When we look at our variables in a quantitative design, we typically look at dependent and independent variables and extraneous variables. For example, where we say viewing violence on television might lead to aggressive behavior in children, then we see the independent variable is causing the effect, which is aggressive behavior, which is dependent on viewing violence. We can look at our variables as being discrete. In other words, it can just have a single value, male or female, or it's continuous, such as what is your age in years. Discrete and continuous variables are measured differently in our statistics. Discrete variables, we can give a pie chart. So many people in my sample were male, so many were female. In terms of continuous, I can give a line graph, or I can give an average or a mean. The average age of my interviewee was whatever. I can perhaps give biographical and demographic variables. And then the important one is we need to understand our levels of measurement. And the levels of measurement typically used are nominal, ordinal, interval, and ratio. And the reason why we need to look at the level of measurement for each one of the questions or the constructs or the variables that we test in our studies when we do quantification is because the level of measurement enables us to do a certain statistical test or not. If your variables are all just at the nominal level, we can only stop at description often. Sometimes we can look for the link between two variables when we do chi-squares and so on, but depending on your level of measurement, you can do more fancier types of statistical analysis, or you need to go and recode your variables into a higher level of measurement, such as, for example, a dummy variable. But I'm talking big statistics now. My take-home message for you is, if you're going quantification, get a statistician to also look at it and aim for, when you measure in your instrument, for your highest possible level of measurement in your variables. Let's just explain these scales quickly. Nominal scale is where it's just a label, A or B, but they do not quantitatively differ, such as, let's say, male or female. Yes or no questions are nominal scale questions. They don't mean that somebody who says no is different from the, it does mean that they've got a different opinion, but it's not twice as big as yes, or any kind of quantifiable difference between them. The ordinal scale is typically when we ask for opinions, such as, how satisfied are you with our service, from being very unhappy to being very smiley face. This is used to represent a non-mathematical idea, such as a frequency or satisfaction, happiness, the degree of pain somebody is in. An interval scale is a numerical scale where there is a known difference, where we can truly say, okay, but maybe the person who is very unsatisfied is very different from the person who is very, very satisfied, and we can go and work out the differences between those. And then the ratio scale is where we really have a quantitative measurement. I want you to look at that example. How many hamburgers can you eat in a day? There's an obvious mistake in that scale, because one says 1 to 2, and the second button also says 2 to 3. So if I eat 2 hamburgers a day, which one do I mark? That is an example of a mistake in a questionnaire. So when we quantify at that level, each level needs to be different from the next, so that me as the person completing your questionnaire mustn't go and think, but I can mark 1 and 2. They must be mutually exclusive. Here are another examples to try. Let's see if we can spot what the level of measurement for each of these questions in someone else's questionnaire is. What is your gender is obviously nominal, because it is just 1 or 2. What is your age in years is ratio, because it's a continuous variable and I can go and work out a mean. How do you feel about the working conditions on the farm? That's a typical scale one, where they ask about, how do you feel about the salary, the safety, the working hours, the sick leave, the possibility to learn something new, and people had to go and rate it between very satisfied to very dissatisfied. That's a typical ratio type of measurement. So scales and indexes are the favorite ordinal measurements, especially for people who are interested in people's perceptions or feelings or attitudes about a particular phenomenon that you're going to research. Students, I'm going to hurry because I see time is running, so I'm going to go very quickly through some of the next few slides. Scales and indexes are often used to measure attitudes and psychological attributes. The advantages is that they cover our concept well. Let's say it's a concept as complex as job satisfaction. It's not just one thing that causes you to be happy in your job. It could be a number of things. They are often quite reliable. We can compare people between, in terms of our scales, how they rate on the scales, and they are simple. And then a question that often comes up from students is, can I use an existing scale, or must I always construct my own scale? You can use existing scales if you get the right permissions. I'm going to quickly go through these. You can always read them at your own. It's different types of scales. And if you're interested in them and you want further readings or you want my opinion, you are welcome to email me at any time. Let's look at examples of conceptualizations, definitions, and key variables. Here's another one. You've seen this example before. The person was interested in factors influencing the early adoption of green electricity by residential users. We said it's typically quantitative. Our concept was early adoption of a new technology. The way it was operationalized into a variable is the perception of ease of switching of use. So people will ask questions, is it easy for you to switch from main electricity to green electricity? Do you trust your green electricity supplier? What are your perceptions of the relative advantages of it? So those were 3 questions in which this very big concept of early adoption of new technology was made measurable through operationalization. Now, quantitative is often more closed. Qualitative is open-ended. Quantitative often used a lot of closed option questions because we probably want to look at cause and effect. Why did this happen? There's a use of theories. Why did it happen? In view of an explanation or a theory. And we assess the differences or magnitude. How much happened? How many times did it happen? What were the differences amongst groups during which this happened? Whereas qualitative is more open-ended. Now, in a quantitative structured questionnaire, you can have open-ended questions, but if you're doing quantification, you want more closed option questions because you want to standardize your observation from one unit to the next. Reliability is quite important in quantitative, and I want to warn you that there's a big difference between how we view reliability and validity in quantification and qualitative. In quantitative, our reliability is, do the instruments that we use, the indicators that we use, produce consistent results? Is there stability in my measurement? If I measured things such as ill health or food security, and we do that through the test-retest one. We look at internal reliability, where some of my scale items get tested against certain others and see if they predict the outcome of the phenomenon in the same way. There's the inter-observer and inter-rater consistency. So if you're talking reliability in quantification, you've got to speak to these different aspects of it. Validity is, do the instruments or the indicators measure what they are supposed to measure? So we need to show face validity. That's usually easy to show face validity of my instrument because it's based on my literature review. Concurrent validity is to look at different ways to measure the same phenomenon. For example, I have several questions asking about job satisfaction or people being absent from work. Predictive validity, will it in the future predict an outcome? Construct validity, is it deduced from theory? And convergent validity, using different methods of data collection to confirm, for example, self-reported behavior versus observation. People can often express an opinion, but then when we measure it against their actual behavior, we see discrepancies. So that's what that convergent validity means. We can ask opinions and then also say, but in the last month, what was your behavior like? Reliability and validity are therefore very rigorous in quantitative approaches and follow set guidelines. Typical concerns in quantification is that we need to look at reliability and validity. We look at explanation, why, generalizability, always back from your sample to your population. Replication, somebody could replicate your study, and if they follow the same steps, they need to find the same outcomes. Precise steps are followed. there's a lot of rigor in our execution. In terms of sampling, we always have a population, that's the total set of units. We draw a sample from that subset. We need to have a sampling frame. If we're using probability sampling, there is some frame that lists the units from which you sample. We use a particular sampling design, probability versus non-probability. Probability is preferable for quantitative designs in which generalizability is important. And then we have statistics and parameters. Sampling is usually random or probability in quantitative designs. And as I said before, in a probability sampling, each unit selected has a known and equal chance of being selected. We need to work out what type of probability sample works the best. We need to give the reasons for our choice. We always need to say, what is our planned sample size when we set off? And what is our realized sample size? What happened in the field? How was it done? What were the inclusion and your exclusion criteria? And are there any sampling inadequacies? In terms of types of random samples, we get simple random sampling. This is for smaller samples where we can list names and just select them through drawing names from a hat or from a container. Stratified is where your population is stratified into strata and a sample is selected randomly in each stratum. Systematic sampling, again, you need to have a sampling frame. You list the elements. You start at a random number and then you pick in a fixed interval until you have the given number of units. You get multi-stage sampling, which is pretty much the same as multi-phase sampling, and you can read those examples for yourself. We get cluster sampling, which is where I cluster the whole neighborhood according to income, and I choose units from the higher income to the lower income in one neighborhood. We get area sampling. We get spatial sampling. I think the first three are the most commonly used ones for smaller types of studies. Simple, stratified, systematic. But you might be interested in the other more complex samples as well. Just make sure that if you're claiming quantification, that you've got a random sample and that you've got a way to work out what your given sampling size need to be in terms of an acceptable sampling error. Data generation techniques for quantitative approaches includes experiments, questionnaires, surveys, structured interviews, structured observation, structured document analysis, and unobtrusive measures. I see that people sometimes use the word questionnaire when they're talking about a qualitative study. In a qualitative study, we've got an interview schedule and not a questionnaire. The moment we've got a questionnaire, we're talking structure in which many of the answer options are kept specifically the same from one measurement to the next so that we can generalize. And therefore, questionnaires are best suited to a quantitative approach. The type of information you wish to collect will determine the type of question styles that are used. Open and closed formats are used, but usually a questionnaire for a quantitative study would have more closed option formats and just a few open format questions. Open format is where the respondent can formulate their own answers. For example, what are the main sources of stress in your life? And the closed format is where we've got fixed categories. For example, mark your gender, male, female. A word on surveys. Questionnaire construction is very important, even more so if you're not in control of your questionnaire yourself. In other words, if you're going to email it or use it online or leave it at someone's house to complete and post back, then you need to make sure that your questionnaire looks professional, that it's easily answerable, and that your goal of Standardizing from one observation to the next can be met. It should always be preempted by an informed consent negotiation. You should pay attention to the format and the question wording. Look at that mutually exclusive categories. Here's another mistake. Age under 21 years, 21 to 40 years. Can you see those overlap? If I'm 21 years old, which I so wish I was, I wouldn't know which one to mark. 50 years and older. Relevancy, clarity, simplicity, and language are important in your questionnaires. You can translate it into the vernacular or the language that your respondents are most familiar with. Just make sure somebody has checked the reliability of your translation. Beware of sensitive questions in a quantitative design. Deliver what you promise. If you say to people, your name and address will not be revealed, but your first question is, please give me your name, or please give me your office number, or very revealing information, then you have not delivered on your promise, and that makes your work unethical. So be careful with sensitive questions and standardized questionnaires. Test your instrument, please. Sometimes we think we ask such clear questions, and when we test it, we realize, no, people didn't understand this word. So test it. Think of the levels of measurement of each variables in your objectives. Match your objectives with your questions. Think of the type of analysis you would want to do. If you want to compare groups, make sure there's enough questions that would be able to differentiate between the two groups. Non-response is a big concern. People refusing to take part or not answering certain of your questions, and that's a crucial part of your objective. But when people got to that part, they just got tired of your questionnaire and gave you no responses, then you have no data. Many popular tools are available for conducting online surveys, such as SurveyMonkey, Boomerang, Google Groups are there, Survey Gizmo, Checkbox, Google Forms, Lime Survey. Each one of these, you can go and look them up, have got particular strengths and weaknesses, and your own formulation of a questionnaire is often sometimes a little bit better than these tools, but try them out. Quantitative, we use structured questionnaires, experiment surveys, secondary data analysis. Do not neglect investigating whether you can use existing data, such as census data, stats essay data, regular household surveys. Sometimes wonderful rich data exists out there, and we can secondary analyze it to meet our own research goals without having to go and research at them ourselves, but always give a reason for your choice. If you design your own instrument, such as a questionnaire, describe how you developed it, the time, the place, the duration, the context where you're going to generate your data, how you recorded and kept your data, what are your ethical considerations. When we analyze our data, we can use SPSS or Excel. Sometimes when you're using a small number of cases, such as what we do in our honors reports, then we can go and count them for ourselves and set up our own tables. But our data presentation in quantitative must always start with the biodemographic description of our sample. How many people were in our sample? What were their household sizes? What were their ages? Give them in nice descriptions as tables and graphs. Please do not have 10 million pie charts. Have some as tables, have some as pie charts, have some as other kinds of graphics, but always make it enjoyable to your reader, make it clear to your reader. Don't just put in the table and think, okay, these people can go and read for themselves how many people suffered from food insecurity. Always interpret your table for the reader. With your tables, make sure that you understand the numbering conventions, how must your table be numbered. Always give it a clear, simple, and accurate title. Always indicate the number of cases. In other words, this is an analysis of 5 households 5,000 households in 2022. Indicate the type of statistic that this is. This is head counts or numbers. These are percentages. These are means or averages, and so on. In terms of graphs, again, understand from your supervisor what the numbering and title conventions are. Line graphs are used for continuous variables at the ratio or interval level. A histogram is used at the ratio or interval level. A bar graph for ordinal data, pie charts for proportions, and scattergrams for your inferential statistics. Inferential statistics is anything beyond your basic descriptive statistics. That's where we now start looking for linkages or interrelationships between variables, where we look at simple correlations. For our nominal variables, we can use phi and Kramer's V, or we can use for ordinal the Spearman, and so on. Discuss this with a supervisor if you're unfamiliar with these statistics, and ask them to put you into contact with a statistician that can help you understand how I'm going to test my work. Tests of significance can be run. There are logistical analysis that we can do. There are endless possibilities if you've got good quantitative data. The strength of a quantitative design. Now, you would know in any proposal or in your research reports and so on, you are usually asked to go and reflect on why you chose a particular orientation. So if you're very clever and you understand why you've chosen your quantitative, then you would go back to these strengths and you say it enables the research and the description of social structures and processes that are not directly observable. For example, the global trading system. I can't see it, but I can go and quantitatively measure it. It is well suited for quantitative description and a comparison between groups or areas. It is good to describe description of change. In other words, over the past 4 years, because of remote working, online bullying has increased, or people's alienation has increased. So it's good to go and look at change over time if you're using a quantitative design. It enables us the analysis and explanation of causal dependencies, of impact, and of social phenomena. What are our limitations? One of our things is always, what is the study's limitations? So if you've chosen quantitative, you need to go and say, I've chosen quantitative and I am aware that this would have certain limitation. The first one is that it often simplifies or compresses a complex reality. Because I can't go and observe all the possible variables that can cause your job satisfaction, I've decided to choose a certain few stemming from my data in a deductive approach, and I understand that this complex reality is now abstract and constrained. It is only applicable for what is measurable and quantifiable. So what you are able to mark as your perceptions on my questionnaire is what I can measure. Anything else I cannot measure. Your dreams, your nightmares, your aspirations, I cannot measure. It presumes a relatively extensive knowledge on the subject matter in order to be able to ask the correct questions. So your background reading is so important. It's difficult to study processes that are dynamic because we've got one view. If it changes drastically tomorrow, I cannot capture that. The descriptions of people's perspectives, their intentions, and their meanings can be difficult in pure quantification. People can often present themselves better in a questionnaire than what they are, especially if you start asking the difficult questions such as smoking habits, drinking habits, gambling habits. People might want to impress you and say something different, but in actual fact, their perspectives, their intentions, or their actual behavior can be a lot different. It can set forth a spurious sense of accuracy because what is measured, because of this view that if it's measured, it's good. We can also be inaccurate. We can be unaware of the biases that we bring to our measurement. Instrumentation takes over, and it can create a barrier between the researcher and the respondent. And this is always so for things that are falsely reported. For example, gambling, drinking, racial prejudice, and so on. Now I want to understand that often students would think, okay, but all these things now were part of a very positivistic past. And right now in 2022, we're in a post-foundational phase of our quantitative paradigms. Does that mean all quantification is thrown out of the window? No. Crude positivism is rejected in this critical turn. Walter Mignolo, if you're familiar with his work from Decoloniality, spoke of crude positivism as a zero-point epistemology. He said it is too detached, too neutral, too much a view from nowhere and everywhere, and it's all about extracting coherent others and a universalism that's part of that generalization. So we must be aware that if we're working in this current time with our research and we're doing quantification, that we must speak to those things and make sure that it's not about data extraction only. Data extraction is problematized as the big data that questions the crisis of representation. Where are the unheard voices? People should have a say in their processes of claiming to generate knowledge about them. In other words, if I go quantification, I should at least ask my gatekeepers to look at my questionnaires to see whether this actually is suitable and whether I will represent them in an ethical way. There's still space for quantification then of structural differences between people, but there's a call to accountability to the complexity. So the only way we can remedy this, if we're doing quantification in this complex reality, is to write a reflexive account and to acknowledge the limitations of quantification. We need to understand the complexities of knowledge creation as fraught with power imbalances, historical problems, that it is contingent on the reality and incomplete. When considering your design, answer the following questions. Is my work descriptional, explanatory, exploratory, and don't see them as mutually exclusive? Your study can include all of them if you want to, but you need to explain why. Some common problems in your quantitative research designs could be that there's a lack of focus. If you don't have your central research question, and I spent some time this morning on telling you how you set up a better research question, that there's a lack of coherence. In other words, you typically used quantitative things, but now you're going qualitative. So now I'm lost. There's too little literature research. People do not like literature reviews, see it as an open thing that it must inform every step of the way. Ill-conceived research designs can bring you problems. You can't, after the fact, force down the theory. So if you started off with theory, you can't go and squish it in afterwards, because we have this very systematized way of going from one research step to the next in quantification. Your evidence must not lack depth and veracity. You must not prematurely close your argument. If you put in a table, discuss your table. Explain why it supports your findings. Juxtapose from one set of tables to the next. Juxtapose your own findings against what other researchers found who did similar research. And do not neglect the raw data. If your raw data needs to be put into an appendix at the back of your report, then do so. But never neglect the raw data just to have the fanciest bit of inferential statistics there. Here are references where you can go and read for yourself. And then I need to say thank you and good luck